Hi again, Pre-Calc folks. We're going to try to get over a couple lessons today, and there'll be a little bit new things to you, especially on this 4-4, but I think you'll be able to do pretty well on it. First of all, 4-4 is this thing called the rational root theorem, and if you remember in mathematics, of course, anytime we use that word rational, we're talking about fractions, and we have been talking about roots. So basically, we're looking for roots that are real numbers, but also kind of fractiony. Anyway, this theorem is a way of predicting what some roots might be just by looking at two things: the leading coefficient, that means the number that is multiplied by the highest powered variable, and also the constant term. If we just look at those two things, we can get some candidates anyway for being rational roots. So anyway, it says, as you can see, if p divided by q is a root of the equation, there's our rational part there, kind of fractiony looking. Then p has to be a factor of the constant term. That would be the number that's by itself. And q is a factor of the leading coefficient. In this case, it would just be a 1. So if we look at this particular example here, could we list the possible rational roots of that polynomial I have there? Well, what I'm going to do is try to write this out a little bit. And my factors of p will go on top in the numerator, and so if I look at that, p again is the constant term. So I look at -6 and some factors of -6. Remember, factors are numbers that you multiply to get a number. Basically, numbers you can multiply together to get 6 are 1 and 6 and 2 and 3. So I just list those, and I would technically then put a plus or minus in front of each of those, because it could be positive or negative of each of those numbers. So I'm going to put a plus or minus in front of all those. That's my numerator. Now for my denominator then, I'm going to look for the same type of thing, but then I look for factors of q, okay? And q then, remember, I look for the leading coefficient, so that is the coefficient of this right up there, and that's just going to be a 1 in this case. And so, of course, only factors of 1 are plus or minus 1. Now, what I have to do is mix and match then to get all my possible candidates. This one's fairly easy because I only have one value in the denominator. If I had more than one, I'd have to kind of mix and match each of these. But anyway, in this particular case, my factors are going to be then plus or minus 1, plus or minus 6, plus or minus 2, or plus or minus 3. Now if I look at this polynomial, I see that there indeed it's a third degree polynomial. That means there are going to be 3 zeros, 3 roots. Remember, not all of them are necessarily real, but these are the possible rational roots. And I haven't done any graphing or factoring or anything. All I've done is look at this polynomial and I can tell those things. Move on to something kind of related. This is Descartes' rule of signs. Here's Mr. Descartes over here. He looked like kind of a long hair for back in his day, I guess. He came up with this. Again, it's a way of figuring out some information about the roots or about the zeros just by looking at that particular polynomial. And so in this case, we're going to actually be able to figure out how many positive roots there are and how many negative roots there might be. And all we're really going to focus on then is something called the sign changes. In other words, changing from positive to negative as I move from coefficient to coefficient. So for instance, here's how this would work. I'm going to look at the first one over here, this particular function p of x. So as I move from here to here, does my coefficient sign change? Well, my coefficient in this case is 2. In this case, remember that minus sign does go with x cubed, so it's -1. So there is a sign change. So then I put a yes or a y there. Now as I move from here to here, I'm going from -1 to -2, so no, it doesn't. From here to here, yep, here's another change from negative to positive, so that would be a yes. And finally from here to here is a no. Now because I have 2 yeses there, that means that there could be 2 positive real roots. And here's the other thing that's a little tricky, is that I can go down or up by 2 when I'm trying to predict these. So I got 2 sign changes. I could go less than, or 2 less than that, 0, that could still be right. Notice I can't really go more than 2 though because of that sign changes, so I could go down by that much. So I say that there are 2 or 0 positive real roots. And we'll practice on these some more in class again just so you get the hang of how this works. But 2 or 0 positive real roots because there's 2 sign changes. Now I'm going to go to the other one here. This one's a little tricky. The negative ones. Notice that it's going to be the same type of thing, but now I have to think about the p of negative x. So notice I looked at the same function, but this time I put negative x in place of x. So let's just kind of calculate what this would equal. Now if I had negative x to the 4th, that's actually going to end up to be a positive number again. So that's going to be 2x to the 4th. Now let's think about this one, negative x to the 3rd. Negative x, negative x, negative x will still be negative x to the 3rd, but then I have a minus sign there, so really what this is going to end up to be is plus x to the 3rd. How about this next one? Negative x times negative x will be positive x squared, but then I am multiplying negative 2 by it, so it's going to end up to be this. Lastly here, this is going to be minus 5x, and finally plus 1 way in the edge here like that. Now again, we're going to look at our sign changes. From here to here is a no. From here to here is a yes. From here to here is a no. And from here to here again is going to be another yes. So this time I can conclude that there will be 2, or once again I can go down by 2, 2 or 0. This time I was looking at negative ones, negative real roots. Now, you might say, well, couldn't you just go ahead and graph this right away and get it over with? And yeah, you sure could. But again, what we're trying to do is just trying to gather some information about a polynomial before we even graph it or attack it in any other means. Notice this does kind of make sense. If this is a 4th degree polynomial, we would expect there would be 4 roots. And you can see that does kind of jive here. I do have 2 and 2 here. We're not considering the imaginary ones yet either, remember. All right. So that's kind of the main ideas from lesson 4.5. This is primarily a calculator-based lesson, I would say, but locating zeros. And again, here's one of the main things that's brought out in this lesson, the location principle. And basically that says if you have a continuous function f of x, and a and b are 2 numbers, so 2 separate numbers, and the f of a, and again when you see that f of a, remember that's the y value. So if the y value of one of these was negative and the y value of the other one was positive, that means that there must be some real zero, at least one of them, between a and b. And it makes sense, I think, if we actually graph this out a bit. So let's look at this particular function here, x squared minus 4x minus 2. I'll try to sketch it out here as best I can. I miss my calculator that I have here, my overhead or my TI-84 that I can put right on here would help you guys out. But anyway, this is what this looks like approximately. Now notice we're not really trying to find the specific zeros. We will be doing that in this lesson. That'll be primarily with our calculators. But can I tell what integers my zeros are going to fall in between? Well, yeah, you can kind of see that with my drawing here. This one looks like it's going to be between -1 and 0. So I'm going to actually say that between -1 and 0 will be one of my roots. And then if I look at the other one here, it looks like that's going to be between 4 and 5. Now, we could look at our table, and we'd be able to tell from the table that those y values would switch signs. They would go from positive to negative when I'm going from x being -1 to 0 and x being from 4 to 5. The rest of this lesson is finding zeros, and we'll show you how to do that on your calculator. And it's quite similar to how we found maximums and minimums and things like that. But this location principle is kind of a key idea in this lesson 4.5. All right, thanks for listening, gang, and we'll see you in class.